Yeah,
Hey,
exactly.
let's go ahead and get kick this off. What I'm going to do, Head, is I'm gonna cede the platform to you, and then I will disappear for a while. So let me start by first of all thanking everybody that has joined this final session of a pretty awesome security group of security sessions. So thank you for joining to hear Head Kovetz speak on behalf of Silverfort. So to introduce Head, I'm going to say that in 2016, that's 5 years ago, Head founded Silverfort and is now the CEO. He's also a member of the Forbes Technology Council. And really, that's, I think those two things are pretty awesome. So, Head, I'm going to, with that, hand it over to you. If you have more to say about yourself, please feel free to do so. I know that you're going to speak plenty about Silverfort. And then, like I said, I'm going to disappear. I am far too pretty. So you don't want that. And so take it away, my friend.
Thank you. Thank you very much. So yeah, I'm the CEO at Silverfort. Before that, I worked in cybersecurity for about 15 years. Started from the Israeli intelligence unit 8200, where I was a group leader. And now for the last 5 years, I've been building and growing Silverfort, and excited to show you what we do here. So I will share my screen. Let's see. And I'll show you a few slides about what we do at Silverfort, and then hopefully a short demo. So Silverfort is doing something that we call unified identity protection. And the idea is that in a lot of companies, identity is a very crucial piece in security and in just the digital workspace, but it's kind of built in silos, right? A lot of companies have one identity solution for their on-prem legacy environment, one solution for their cloud applications, one solution for their privileged identities, and these solutions don't really interact. Some of them don't have all the capabilities. So what we do is help enterprises unify the security controls across all the different identity platforms, even the ones that don't support secure authentication today. So we can protect even systems that there's no way to build secure authentication and access into. And we can do that without having to install any agents on them or put proxies in front of them or modify them. So think about Silverfort as a way to extend secure authentication everywhere, even to systems and access tools that are vulnerable today and that pose a threat from attacks and also from ransomware that is spreading in networks using all these tools. So before we start with the solution itself, let me say a few words about where we actually help companies, what kind of challenges. So today, a lot of companies have different solutions for identity and access management, for secure authentication, but it's still pretty difficult to apply them everywhere. And what we normally hear from companies is that one challenge is the fact that they have multiple identity platforms. Active Directory on-prem, Okta or Azure AD for the cloud, Ping Federate or ADFS for federation, CyberArk for privileged access. And all these solutions, because they compete with each other, they don't really share the data, they don't share the policies. It's kind of inconsistent. In addition, a lot of companies are trying to extend protection to more assets like servers and endpoints and other applications. And that usually requires the deployment of agents and proxies or making changes to those applications. That's not very scalable. In some cases, it's not even possible. There are some systems where you just can't build secure authentication because they are legacy or they are not web-based. Think about infrastructure, databases, file shares, industrial systems, medical systems, command line interfaces, and many more things that you just can't build secure authentication into today. And in some of these cases, it's not just servers that you can't protect at all. Maybe you can protect one way of accessing them, but there are alternative ways that are not protected. So you could implement secure authentication for, let's say, remote desktop into your servers, But as an attacker, I can just choose to use another access tool. I can use remote PowerShell or PSExec or WMI or connect to a shared folder on that server. Today, there is really no way to secure a server from access if you have the right password. Even if you feel like you installed multi-factor authentication on it, there's always another way to access it with just a password. And the last challenge is non-human identities, service accounts. They are especially difficult to protect because, first of all, we don't always know where they are and what they're doing. And in order to protect them, we currently need to rotate the passwords, to change the passwords. And that's, first of all, not fully secure because it still gives the attacker usually a few months to use that password. But more importantly, it's not always possible. There are many cases where you just can't modify the password of this service account because of all the dependencies, because you don't know what's going to break if you change the password. So these are challenges we hear from a lot of enterprises in all sizes, all industries. And because of all these challenges, most of the systems, or at least the interfaces, the ways that people can access different resources in most networks, whether they're on-prem or in the cloud, are still not protected with the kind of secure authentication that companies are looking for. And that's what attackers are leveraging every time. And again, ransomware is a good example of that. If you have a ransomware in your network and it's trying to spread, it will not do it with remote desktop or web access. It will do it with command line interfaces that your authentication solution just doesn't see. So at Silverfort, we took a different approach and we call it unified identity protection. It's a pretty unique solution, very innovative technology that basically is built in the back end of your identity infrastructure. So instead of installing agents or proxies or modifying your different applications, we are sitting behind your existing identity platforms, your Active Directory, your ADFS, your Okta, Azure AD, Ping, Radius. We see across all of them, even the ones that don't have any security controls today, like Active Directory. And we can act as the unified second opinion. So we can enforce policies, we can add protection that is unified and applies everywhere. The way that this works is we have all these different identity platforms that companies are using. Could be on-prem, could be cloud. Some of them have security features, some of them don't really. And we allow the endpoints and the servers to continue to authenticate to them directly. Again, no agents on the servers, no proxies in between. As far as the endpoints and the servers and the applications are aware, they are still authenticating to the same directory. But now in the backend, we add Silverfort as kind of a unified second opinion in the backend of all these IAM platforms, all these directories. The way we configure the directories to communicate with our solution is something that we built with each of the vendors. We work with Microsoft, with Okta, with Ping, with others to create this integration that is very seamless. So there are some other solutions in the market today that are focused on protecting, let's say, Active Directory or privileged access or one piece of it. And they are built into these directories in very intrusive ways. We found a way, because we worked with these vendors, to have a very non-intrusive way of connecting to all of them as acting as the second opinion, meaning that we can now see the full picture. We can see that somebody is connecting to this resource in the cloud and also to this legacy system that only supports Kerberos or NTLM or LDAP, and we see all of that and we can apply policies anywhere. We can block a certain access, we could trigger MFA. If it is MFA, it can be any MFA that you already have, or it can be our MFA. I mean, MFA is pretty commodity at this point, so you can use whatever you want. But the difference is you no longer need to build it into the applications or into the servers. You don't need to do that anymore. So we are kind of acting as an abstraction layer. We are sitting behind the directory. The server or the application, they still believe that they're authenticated to the same old directory in the same old protocol. But actually, we are sitting there in the back and triggering the MFA or blocking access if the access seems suspicious. And then just telling the directory, yes or no. I mean, that's okay. You can grant access to this resource. Or no, please don't grant access. And the endpoint and the servers, they just see this as the regular response from the directory. So they have no idea that there's an additional layer in the back. This is why we can achieve two things that weren't possible before. One is adding protection on top of these identity platforms where it's not possible today, like Active Directory. And two is apply a unified layer of policy enforcement across the different identity platforms, even the ones that do have security controls, like Azure AD or Okta, but they just see only their own piece today. They don't have the broader context. So there are a few use cases to this solution, and this is the last slide I'll show you. After that, I want to show you the solution itself a little bit. So one use case is extending multi-factor authentication to assets that don't support it. That's what I just talked about with all these legacy systems or command line tools like remote PowerShell, file systems, databases, things like that. We can protect them without modifying them, even if there's no other way to build it into them, because we are sitting behind the directory and triggering the MFA in a way that the server itself is completely unaware of. The server is still doing LDAP as far as it knows. The second thing is we can look at all these authentications and apply risk analysis to trigger those adaptive policies, show you where there are certain threats or suspicious behavior, and then automatically respond to it by triggering step-up authentication or blocking access or sending an alert. So our advantage here is that we just see more data, more authentications than any other authentication solution. Because again, we are sitting across the different legacy and modern identity platforms, seeing across all of them, not just the initial login, but also every specific resource access. So we can identify and block things like ransomware trying to propagate in the network. As we see those patterns, we can just stop these authentications. There's no other tool that can really do this in real time, stop ransomware from accessing anything, because we identify this kind of authentication through those command line interfaces that it's using. We can also look at other types of lateral movement. We can see things like brute force attacks or the use of legacy authentication protocols and all kinds of things that really a long list of things that we can share with anyone who's interested. And that allows our customers to achieve a zero trust security positioning, where it's not just the network aspect with some kind of proxy, but it's really sitting behind the identity platform and seeing any access, even if it's inside the network, for a more holistic zero trust protection. The third use case, which is very popular for us recently, is protecting machine-to-machine access. So service accounts, these are your non-human identities. These are the ones that you just can't do MFA for because they can't use a second factor of authentication on their phone or insert a code. These are automated processes. And the other way of protecting them today is rotating their passwords, but that's, again, not very achievable. A lot of dependencies, a lot of risk if you try to do that. So most companies just don't, at least not for most of their service accounts. Because we are sitting behind the directory, we are in a unique position to see everything service accounts are doing, understand who they are, what they're doing, and then blocking access that is outside of what you want this service account to do. So even if someone has the right password for this service account that they stole, they will not be able to use it to log in from anywhere else or access anything else except what this account was restricted to use, even though you have the password and it's a legacy protocol going to Active Directory. We can still do that, and there's no need for password rotation, so you don't break anything. And then the last use case, which is very strategic for customers who are on this journey to move to cloud identity, we can help you bridge even legacy authentication into your cloud identities, cloud single sign-on platform. So if you're using Okta or Azure AD, and right now you probably just have your web applications in there, because these platforms are really built for web apps. But you got other resources in the company. You have endpoints, you got infrastructure and databases and file systems and industrial systems and all these command line interfaces. And they are not supported by Okta or Azure AD today. These solutions are built for web access. But Silverfort can actually act as a translator between them. We can see those legacy protocols coming in and we can translate them into an authentication protocol that Azure AD or Okta can understand. So you can actually authenticate your legacy non-web assets into Azure AD, into Okta. You can centralize all your policies, all your visibility in there. You can have the same user experience for all these legacy non-web systems that you do for your cloud identity or cloud single sign-on, even passwordless login. right? Imagine doing passwordless login or single sign-on with Azure AD to a remote PowerShell session into an on-prem server. That's what we can do, and we can really consolidate your IAM and let you manage it from one place, but also improve user experience. Again, this is only for companies who are on this journey. If you're not, we'll easily protect your hybrid environment without having to, really move anything around between those different identity platforms. So I want to quickly show you a demo. Let me go back to platform here, and I'll share another screen. I want to show you what the product looks like. And then we'll try to save a few minutes for a discussion. I'd really love to do that. Okay. Can you see my product dashboard, John? Okay. Let's hope you guys can see it. So what you're seeing here, this is the Silverfort dashboard showing you authentications that are happening in this environment in real time. So these users connect to these resources with all kinds of protocols. You got your legacy protocols, your cloud native protocols, all in one place being monitored and being controlled. You can get all kinds of insight about that. So you can see, what users really have in terms of permissions and all kind of risky parameters, or just users that are doing suspicious behavior. Like we can see a user here that has a high risk. So we can see what it's doing, and we can see that this user is under a possible brute force attack. And it's also a service account, a non-human identity that attempted to do interactive login. That's not something a service account should be doing, as opposed to a human, right? So all these data, all these logs, you can export to your SIEM, or you can investigate. You can really see, what users are accessing across all the different protocols, all the different identity platforms, with risk scoring, really understand, what are the risky parameters about this access, and what is the policy, or what is the parameters. You can export it and you can create alerts. But of course, the more important part is when you actually want to start preventing all those threats. And this is where you build a policy and you say, if someone connects to, let's say, this identity platform, these are the ones I have here on this lab environment. So let's use Active Directory as an example. If someone connects to it and they belong to this group, let's say Hyper-V administrators, and they try to connect to any of these destinations, then I want to take action. Now, the resources, I think that's one of the best things about Silverfort. This can be anything. Windows, Linux, databases, domain controllers, hypervisors, web applications. And for each of these, we go all the way down to the service level. So maybe I just want to protect HTTP, or maybe just CIFS for file share access, or maybe just RPC. I can go very granular if I want, to the level of services that no other authentication solution can really protect today, as far as we know. And I can also, either do it statically or leverage the risk engine. Say only if the risk score is above a certain threshold, or maybe even pick specific risk indicators. Let's say if there's let's say a suspected lateral movement attempt, then I want to trigger MFA. So my action can be MFA, but it can also be allow, deny, maybe send an alert. You can do many different things. You can even send it to Azure AD, as I mentioned, or maybe to Okta. If it is MFA, what kind of MFA do I want to use? It can be any third-party MFA or the Silverfort one. So you can choose if you want to save costs, use the Silverfort app, which comes for free, or you can use any authenticator that you already have in one environment, but extend its coverage to be able to protect systems that it doesn't natively support. So think about using Okta or Microsoft Authenticator for file share access, or some kind of legacy industrial system, or many other things. So the last thing I want to show you is around the service accounts. So Service accounts require a special treatment because it's not only that you want to protect them, sometimes you don't even know what they're doing, what should they be doing. So it really starts with discovery. So first, we show you all the non-human identities, the service accounts in your environment. These are all the ones that look like non-humans, either because they just have attributes or names or group memberships that look like service accounts, or because of their actual behavior. So maybe the way they behave is very non-human. This is a good example. So this is not a human doing the same number of authentications every hour with these spikes, doesn't sleep at night, doesn't rest in the weekend. This is not a human user. Now, even if the name was Mike, maybe it's just some regular user that gave his personal credentials to run some application or to run some scheduled task. People do that because they don't want to go to the trouble of creating a dedicated service account. So we map even those based on their behavior with machine learning. And then once we get these results, which are very accurate, I'll tell you, we show you what they are doing. So these accounts connect from here to there this many times. That's how predictable they are, how risky they are. And then automatically suggest a policy for me with a least privilege approach, a zero trust approach. We saw that this service account normally connects from these hosts to these resources in this frequency. Now, maybe in the beginning, if you're not sure this is really all it's doing, start by just alerting. So if there's anything outside of that, just send me an alert. After I see that there are no false positives, and this is really what this account is designed to do, I'm going to apply blocking so that everything outside of this will be blocked. Or it doesn't have to be exactly this. Maybe I want to modify it and add more permissions. But at the end, even though this is a regular legacy Active Directory account, that if you have the right password or password hash or ticket for that, you can do whatever you want normally. Now you will not, because Silverfort will sit in the backend and say, no, you can't access this resource. This is not what you normally access. And of course, this doesn't have to be done by individual service accounts. You can do by entire groups, maybe even groups of servers as your sources and destinations, and really build it to scale. We have customers using this product that are very large enterprises now, all the way up to Fortune 100, even Fortune 25 companies that are using this solution across all their employees. So it's really designed for scale. I think that, we work with small companies, we work with large companies, but I think the challenge is really everywhere. Every company, no matter what size, usually have a lot of systems that are not protected with secure authentication. Because usually where secure authentication really is for your VPN, for your modern web applications, maybe a little bit of remote desktop scenarios or workstation login. But everything else, all these other things I mentioned, infrastructure and databases and command line tools and file shares and all these things that attackers use. And these are the real things that attackers use, right? They normally focus on these legacy file shares or command line interfaces. We can protect even those, whether it's for a human or a non-human user. So this is what we do in high level. Let me know if you have any questions, and then we can save these few minutes for that. Yeah.
Good. You can hear me. I have some questions from others as well. So first of all, thank you. Wonderful summary and description of the Silverfort product. Thank you so much. I kind of look at there's an aspect on one of your slides you were kind of describing the flow, and I think of man in the middle, and it's kind of like but when you hear man in the middle, you're thinking MITRE attack or kind of an attacker technique, but really you guys are more of a security facilitator versus the attacker. So yeah, well done.
Exactly. And we even build the solution in a way that we are not actually in the middle, right? We are in the back.
Yeah.
That's good for scalability and for
man in the back of the room.
Yeah, exactly. Because if our solution, if you turn it off, doesn't have to be a point of failure. So that's important too.
Yep. Perfect. Well stated. How does Silverfort, how do you discover service accounts? It's kind of
So we use a variety of methods. some of them are more based on attributes, or group memberships or naming conventions like SVC, all kind of things like that, that are very clear. I mean, a lot of people know this already, and we just automate it based on knowledge from a lot of customers. But then the second part is more behavioral. So we, using data that a lot of customers agreed to share with us, we built an algorithm that can tell the difference between a way that a human acts in the network and in terms of the authentications themselves, and a non-human or a machine, which is usually more scheduled, doesn't rest at all in the night or at weekend. And we can pick up on this machine-like behavior when we can say this is non-human. And by the way, we'll pick up on it even if it's happening in parallel. So we have an account that a human is operating, but also is running some scheduled tasks. We'll show you, hey, this at least part of the use of this account is automated.
Great, awesome. We're going to have 3 minutes for 2 questions. So let me ask, kind of in the spirit of attack types, we just in the middle. How are you able to stop pass the hash attacks?
So pass the hash is a great example of an attack that uses those interfaces that nobody else can protect today, because it steals the secrets, the hash. And then it uses a legacy protocol, NTLM, which unfortunately many systems still support and almost nobody can really get rid of. I mean, even if you don't use it a lot, it's still available. Usually it's possible to use it. And they're going to move around with this stolen hash without even knowing the password. We can see even these authentications, even these kind of protocols. And when we see something that looks like Mimikatz, this kind of pass the hash tools, and there's a way to see that, we'll just trigger MFA, or we will simply block the authentication. So a lot of red team assessments, the customer always like to show how they can stop these kind of attacks. And of course, real life incidents where we actually showed customers that we can stop this, even when used by ransomware in some cases.
Awesome. So the last question that I have, it kind of partners with the fact that this product is good. So it leads me to ask the question of what is the pricing model?
So
how can we fully leverage this thing?
Yeah, so we price it per user, and we have 2 models. It's a license per user, but one option is you protect all the employees in your company. That's the cheapest you can get per user. So just based on your employee count, even if some of them have multiple identities, that's okay. And the second option is you only protect a subset of them. So we monitor everyone because that's something we want to do anywhere. So we will monitor everyone just to understand the risk and build this baseline. But we'll only get you licenses for protection on these users, whether they're human or service accounts that you actually want to enforce protection for. Either way, it's usually an annual subscription. And if anyone has any specific need, just kind of give us your size and what you're looking to protect, and we are very open about.
Send us your shirt size, and we'll get you fitted correctly.
Yeah, and by the way, we also do free evaluation. So if you just want to try it, whether it's in a lab or in your real environment, very easy to do. It's a very simple product to install.
Awesome. Thank you so much. I think we nailed the time. Tremendous presentation, awesome summary of the product. And Head, thank you for joining us all the way from Tel Aviv with jet lag. No small feat, and very much appreciated. And thank you for being this really awesome.
Thank you very much for inviting
conference. Me. Absolutely.
And thanks everyone.
And
for
so
listening.
for everybody else, if we go back to the main stage, Head, you as well. There is an awesome and final session on the powerful women in cybersecurity, and that's going to happen at the main stage right now. So let's get on over there. Thank you.